Hey everyone, welcome to your first at-home notes video. I believe on Thursday we left off right around here, going through this idea of how electrons are organized around the nucleus. So just to add a couple things that we did on Thursday. So on this diagram, these lines, so these are representing energy levels, right? So this is an energy level. Well, they're both energy levels. But the outermost energy level is the one that we refer to as the valence shell. What that means is those are the valence electrons, right? Valence electrons of the outermost shell are involved in bonding. Okay, so as we went through the rules, so hopefully you got those rules down, right? 2 electrons in the first energy level, 8 up to 8 can fit in the second, and up to 8 in the third, and remembering how you can figure that out from the periodic table. Please bring questions to next class, absolutely, if you've got any. So what I want you to see in these outermost shells, in the case of carbon, you can see that there's just one unpaired electron at each of the compass positions. So that means there's this empty spot where electrons could pair up. That means that carbon can make up to 4 bonds, okay? We can talk more about that next week if you're not clear. If we look at this nitrogen, there's 2 paired up at the top, but then there's these 3 unpaired ones, right? If you follow the rules, put them around the compass positions, and then start to pair them up, you can see that nitrogen can make up to 3 bonds. And then this oxygen at the end here, it's got 2 pairs, right, that are paired up, and then these 2 single ones where other electrons could come in and form bonds. So it can make 2. So I'm going to pause the video. I want you to pause the video, and I want you to try this one. What would the element neon look like if it had an atomic number of 10? Draw its atomic structure as these ones are shown over here. Pause the video, and also I want you to try figuring out, can you figure out the number of protons, electrons, and neutrons for the isotope shown at right, iron 56? And how about the element phosphorus? How many electrons and what would its atomic arrangement look like? When you start the video, I'll have the answers up. Okay, so if you did neon correctly, an atomic number of 10 means that it also has 10 electrons. So 10 electrons, we would have 2 in the first, 8 in the outer, and what I want you to know, remember that valence, well here, the valence shell, valence is full. And what that means, oh my pen, sorry, but that valence shell is full, and therefore it doesn't form bonds. Remember neon, it's that one that I was talking about earlier. It exists as individual atoms as an element. It doesn't have any unpaired electrons, so it doesn't like to form bonds with anything, as opposed to these ones over here. And it's an inert gas. We can talk more about that if you have questions. As far as using the isotopic nomenclature here for iron, so because the atomic number shown here is 26, it therefore has 26 protons. The number of neutrons, since the mass number is 56, we take 56, subtract 26 to get the number of neutrons of 30, and the electrons has to be 2 less than the atomic number 24 to give a net charge of +2. Again, please, if you have any questions, bring them up. And I think we did phosphorus in class. It's going to have an atomic number of 15, so therefore it has 15 protons, and therefore it'll have 15 electrons. And so 15 electrons will look like that. 5 in its outer shell, 3 unpaired electrons, and that means that it could form 3 bonds where it could receive electrons from up to 3 electrons, forming those bonds. Again, my pen is just awesome. All right, finally down here at the bottom, we're going to get into these notes here in terms of how does this bond actually take place, okay? What I would like you to do is I'm going to pause the video, in a moment, and I'll send you over here to our videos from class, and it would be a great idea just to watch. Did I put that in? Oh, maybe I didn't. That's okay. Let's leave it out, and you can we can watch it in class tomorrow to give you the visual of how bonds form. So let's look at what's happening in terms of how the bonds actually form. There are two major types of chemical bonds, okay? And it has to do with each individual's atoms, what we call electronegativity. Essentially what that is this attraction for these electrons in the outermost shell. So every atom, based on its atomic structure, has a certain attraction to another atom's electrons, and that kind of dictates the bond that's formed. We call this attraction electronegativity, right? Attraction for a bonding pair of electrons. So bonds are formed either when atoms exchange electrons to try and fill up that outer shell, or they share electrons. So they can either exchange electrons or share electrons. Okay, and so the first type of bond is what we call an ionic bond, and it results from an exchange, right? So a transfer of electrons. Let's write that down. So ionic bonds occur between usually metals. Man, I'm really struggling, I'm sorry. Metals and nonmetals, okay, of elements. And metals lose electrons to nonmetals. And so what happens is these charges develop. Remember, we were talking about charges and how if you have less electrons, you're going to have a positive charge. If you have more electrons, you're going to have a negative. So if we look at sodium and chlorine, now, I don't know if anybody knows the common name. I'll leave that out there, and maybe you can tell me what the common name of sodium chloride is. But this sodium atom has one electron in its outer shell. And if you look at chlorine, it has 7 in its outer shell. And it's missing 1 to make it complete. And if you think about why complete, right, is important, go back to this neon and remember when it has a complete outer shell, the element is, or the substance can be very stable, right, and achieve kind of a lower energy, stable. So all elements, when they're reacting, they're trying to achieve this sort of stable arrangement, but they achieve it through bonding and exchange of electrons. So this sodium is going to, well, the chlorine is literally going to rip this electron away, right? The chlorine really wants that electron. It's more electronegative. So it pulls that electron away, but by gaining electron, it makes it negatively charged. And the sodium losing that electron makes it positively charged. And if you remember those laws of charges from grade school, opposite charges attract. And so this is where the bond comes from. The bond is a result of this plus minus attraction holding those two atoms together. And we call it an ionic bond because it forms ions. But overall, we write the formula as just NaCl because it's neutral, because they've got an equal positive charge and a negative charge, and so they cancel each other out, but they're what's holding the bond together. Underneath here, we've got covalent bonds, and covalent bonds usually result between, so this results between nonmetals, which share electrons. So they don't actually exchange, they share electrons, forming the bond, forming a covalent bond. So sharing electrons. Now here's something that's kind of interesting, between non-metals. Remember our most essential elements of all biological molecules? Remember those carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur? These guys are all non-metals. So guess what? All of our biological molecules that form are made up predominantly of covalent bonds. Carbohydrates are formed by covalent bonds, proteins, lipids, right? Because they all contain these elements, which are all non-metals, they all tend to share their electrons. Here's an example of carbon and hydrogen, and here's how it operates slightly different. So you've got this carbon with its 4 unpaired electrons, and each hydrogen has 1 electron. So what can happen is each hydrogen is going to come in, and what's going to happen with its 1 electron is its 1 electron will be attracted to the nucleus of this carbon at the same time as the carbon electron would be attracted to the nucleus of the hydrogen. But it's not a complete exchange. You'll see that there's no charges. They're just sharing. And that's because their electronegativities are so similar. Here, the sodium and the chlorine, the electronegativities are really different, right? Chlorine is really electronegative, so it really wants that electron. It wants it so bad, it rips it right off of the sodium. And whereas down here, the carbon and the hydrogen, their electronegativities are very similar, not exactly the same, but they're similar enough that neither one rips the electron, they share them. All right, and so that's how various bonds between different substances are shown. And if we go back to that periodic table way back, right, we can see, if you remember from grade school, your non-metals are found over here and your metals are found over here. And so it kind of makes sense. Remember how I said this was organized based on properties? So when you have something over here joining with something over here, these guys are so electronegative. You know, if chlorine or bromine was to join with magnesium, it's going to be an ionic bond. But look at, if you join carbon and oxygen, they're almost right side by side. They share electrons, and it's going to be covalent. All right, I hope that makes sense. Bring any questions you've got to class, and I believe this video is online, and I want you to watch that before starting the next set of notes down below. Okay, so once you finish this one, there'll be a second set of notes following.